Unit 4, Session 2. Next topic is board description, serial communication standards. So, this is a Raspberry Pi board. Now, what are the different labelings that you should know in Raspberry Pi? We are using Raspberry Pi 3 model board. So, for that we are learning the description. So, first here it is mounting holes, and this part is called as Bluetooth or LAN connection, and you can also see the symbol Raspberry Pi fruit symbol. Next, this is called as display connector, micro SD card. Next, you have Broadcom processor. This is the main thing or a brain of the total Raspberry Pi board. Broadcom BCM 2837. This is called as Broadcom processor. And next you have different types of ports here. This is 5 volts micro USB port, and here you can connect HDMI port. Next, this is called as camera port, CSI camera port, and this connection is called as video or audio socket port. And here you have Ethernet port. Next, this one is called as Ethernet control chip, and these are the 2 slots of USB ports, and these are the 2 slots. Totally you have 4 USB slots. So, you can connect 4 different things to work multiple applications at a time, and this one is an reset board button. If you are connecting it correctly, then you can see that the power will be on in this session, power over Ethernet header. You can also call as PoE. And the main thing are these GPIO pins. You will be having 40 pins in this Raspberry Pi 3 model B board. So, these are called as GPIO, general purpose input output pins. So, here you are going to connect different types of sensors. So, whatever we have seen in the diagram, same thing we are learning here, processor and RAM. So, Raspberry Pi is based on ARM processor, which is of 16 4-bit ARM V7 Broadcom BCM 2837. It has quad core computer using at 1.2 gigahertz. Next, USB ports, you have 4 different types of ports. The ports on Raspberry Pi provide a current up to 100 milliamps. Next, Ethernet ports. Raspberry Pi comes with a standard RJ45 Ethernet port. We can connect an Ethernet cable, or you can also connect USB Wi-Fi adapter to provide the internet connectivity. Next, HDMI port. HDMI port on Raspberry Pi provides both audio and video output. So, we can connect the Raspberry Pi to a monitor using this HDMI cable. So, suppose if the system is not having HDMI cable, that means you are having cable like DVE, digital video interface. So, for this type of systems, you can use HDMI to DVI adapter cable. Next, composite video output. So, Raspberry Pi comes with a composite video output with an RCA jack. So, this is a company name that supports both PAL and NTSC video output. Next, RCA jack can be used to connect old televisions. Next, audio output. So, Raspberry Pi has 3.5 mm audio output jack. So, using this audio jack for providing outputs in the older versions of TVs. If it is new version, then you can use HDMI as an output. Next, GPIO pins. Raspberry Pi comes with a number of general purpose input output pins. These are 4 types of pins are there. Among those 40, there are 4 types of different types of GPIO pins. Raspberry Pi through GPIO pins along with I2C interface. Next, SPI interface pins, and you also have serial RX and TX pin, receiver transmitter. In the same way, you have serial communications. One type is SPI, another type is I2C. So, these are the 4 different categories among those 40 GPIO pins. Next, display serial input interface, DSI. So, this interface is used to connect LCD panel to Raspberry Pi. Next, camera serial interface, it is used to connect camera module to Raspberry Pi, and you have different types of LEDs in Raspberry Pi. ACT means SD card. For accessing SD card, you have a LED. PWR 3.3 volts power is present. FDX full duplex LAN connection, and LNK link or network activity for connecting the network, and then you have LAN connection. So these are the different types of LEDs. SD card slot. So this slot is built in for installing operating systems. So SD card slot on Raspberry Pi is located just below the DSI, display serial adapter. And power input, Raspberry Pi has a micro USB connector for power input. So the 40 GPIO pins, the diagram is expanded here. These are the 40 GPIO pins where you have different types of pins. You have ground pin, you have serial connection pins like SPI, I2C pins, and you have PWM pins. PWM you have seen pulse width modulation pins. So clock pins, ground pins, all together you are having 40 pins. HDMI cable is used to connect the monitor and the Raspberry Pi. So you will require this for connecting the keyboard or mouse or any adapter to power the line cable. Next topic is Raspberry Pi onboard serial communication standard. So you have three different serial communication standards, UART, next SPI and I2C. Among that, first one is UART, UART. It is a multi-master communication protocol. So this protocol is quite easy to use and it is very convenient for communicating between several boards like Raspberry Pi to Raspberry Pi or Raspberry Pi to Arduino, etc. So you can connect different types of boards using this UART serial communication standards. So the pins which represent UART are pin number 8, pin number 10. Among those 40 pins, pin number 8, pin number 10 are specifically for UART serial communication standards. Among this, one will be the transmission pin, one will be the reception pin, that is receiving and transmitting the data using serial communication. Next, for using UART, three different pins you require. One is ground, another RX and then TX. Ground, you are connecting global ground, connecting the circuit. Next, RX, reception, which will connect the pins to TX pin of another computer. So if you observe, when you are talking about RX, then you will connect to TX pin. If you are talking about TX of Raspberry Pi, then you are going to connect RX of another component. So this will be the indirect RX to TX, TX to RX. Next, by using a UART to USB converter, you can communicate through your laptop to Raspberry Pi. So basically UART is a serial communication where you can connect different types of devices and transfer the data. Next type of serial communication is I2C. It is a two-wire master-slave bus protocol. It can have multiple masters, but mostly we will work with only one master with multiple slaves. So the master is the Raspberry Pi and the slaves are all connected on the same bus. So each slave has some unique ID so that Raspberry Pi can identify to which slave it is talking or transmitting the data. So among those 40 pins, if you see GPIO 3 and 5, these two are specifically for I2C serial communication. So to connect or to use this I2PC pin, we need 3 pins like ground, SCL and SDA. SCL is serial clock line, SDA is serial data line. So these are used for exchanging the data. First, SCL is a clock of I2C, connect to all the slave SCL to SCL bus. In the same way, SDA data line, it is used to exchange the data. So connect all the slaves of SDA to SDA bus. So what the note here you should remember is SDA and SCL pins on Raspberry Pi are alternative functions for GPIO 2 and 3. GPIO 2 and 3. So when you want to use this serial communication, you need to install the libraries related to this. So you can configure those libraries and use the alternative functions. For this you need to install the libraries basically for this type of communication, that is I2C. Next type of serial communication is SPI, Serial Peripheral Interface. It is a synchronous serial data protocol used for communicating with one or more peripheral devices. So SPI is yet another hardware communication protocol. It depends upon master slave bus protocol and requires more wires than the I2C serial communication, but configuration is running fast in SPI compared to I2C. So among these pins, SPI are 19, 21 and 23 pins. Here 35, 24, 26, 36, 38, 40. These pins are specifically for SPI serial communications. Next, two SPI pins, by default we call it as SPIO and 0, SPI 0 and SPI 1. For I2C, if you see, SPI uses the alternative functions, GPIOs for using SPI. So for connecting through this SPI you require 5 pins. Previously you have seen for I2C or UART you require 3 pins, but here for SPI you require 5 pins, that is ground, SCLK, MOSI, MISO. So ground is here you are connecting to the ground of the circuit. Next, SCLK, clock of SPI, connect all SCLK pins together, it is a clock pin. Next, MOSI, meaning of MOSI is master out, slave in. So this is the pin to send data from master to slave. In the same way, MISO means master in, slave out. So this pin is used to receive data from a slave to the master. Next, CS. CS here means chip select. You need this CS per slave on your circuit. How many slaves you are connecting? For each slave you require CS. By default, you have two CS pins like CS0, which is GPIO pin 8 number in the board, and CS1, it is GPIO number 7 in the Raspberry Pi board. So you can configure these two pins and use the serial communication. Next, Raspberry Pi serial communication standards. For transferring the data, different types of schemes available. So among them, serial communications, you have two different types of methods: synchronous communication, asynchronous communication. Synchronous communication means it transfers block of data. At a time, it transfers block of data in a form of packets or frames. Next, it requires clock signal. Synchronous transmission is faster. Synchronous transmission is costlier one. So here in synchronous transmission, time interval of transmission is constant. That is important point to note in synchronous. So in synchronous transmission, there will be no gap present between the data. Once you are starting to transfer data from transmitter to receiver, you will be having no gap. So the data blocks are grouped and spaced in regular intervals, and these are preceded by special characters like SYN. SYN here is synchronous ideal characters. So the diagram represents like this. Suppose the data is flowing from transmitter to receiver. This is the data which is continuously flowing here. You don't have interval for transmission in between, so it is constant. And the other bits, ideal bits, you can represent as SYN, synchronous transmission frame format. And after SYN character are received by the remote device, they will decode and use the synchronous for connection. So after the connection is correctly synchronized, data will be transmitted. That means the data transmission will begin once it is received by remote device. This is a synchronous type of serial communication. Example, SPI, I2C and Ethernet. Next type of serial communication model is asynchronous. So asynchronous will transfer the data byte at a time, 1 byte at a time. Here no need of any clock signal. Asynchronous data is comparatively slow and it is economical to use. In asynchronous transmission, time travel of transmission is not constant. We have seen in synchronous, time interval of transmission is constant, but here in asynchronous it is not constant. So it is random. Now in asynchronous transmission there is a gap present between the data. So if you see the format or a diagram, if you represent asynchronous, transmitter is there, receiver is there. So you are transmitting the data. Now whenever you are starting the transmission of data, you have the two bits called as start bit and stop bit of data. Once you say start, the transmission is going to begin, and before receiving the last bit, you are considering it as stop bit. So this is, we are calling it as gap between the data. And if you see this diagram in a form of frame, then start bit 0 and data is been transmitted, stop bit 1. Examples UART, USB and then CAN. So this is one type of serial communication model.